sklearn, cluster, agglomerative clustering. Description: performs hierarchical clustering using a bottom-up approach, where initially each data point is considered a single cluster and then pairs of clusters are merged based on a similarity measure until a single cluster remains. Inputs: data matrix, a feature matrix of shape n samples. N features representing the data points to be clustered. Number of clusters: n clusters, the desired number of clusters to produce. If not specified, the number of clusters is determined automatically. Affinity: the metric used to compute the distance between two samples. Common options include Euclidean, Manhattan, cosine, etc. Linkage: the linkage criterion determining the distance between sets of observations. Common options include WOD, complete, average, single. Outputs: cluster labels, an array of shape n samples, indicating the cluster label for each data point. Steps: compute distance matrix, calculate the pairwise distances between all data points based on pay. Specified affinity: merge clusters iteratively, merge the closest clusters based on the linkage criterion until pay desired number of clusters is reached. Fine-tune parameters: number of clusters, n clusters, the desired number of clusters in the final result. Affinity: the metric used to compute the distance between two samples. Linkage: the linkage criterion determining the distance between sets of observations. Challenges and fixes: computational cost can be expensive for large datasets due to the computation of the distance matrix and the iterative merging process. Efficient distance metrics: use efficient distance metrics like Euclidean or Manhattan distance. Early stopping: stop the clustering process before reaching the desired number of clusters if computational resources are limited. Choice of linkage criterion: the choice of linkage criterion can significantly impact pay. Clustering results: experiment with different linkage criteria, try different linkage criteria WOD, complete, average, single to find the best fit for the data. Consider data distribution: the choice of linkage criterion should be based on the shape and distribution of the data. Determining optimal number of clusters: the optimal number of clusters is often not known beforehand. Silhouette coefficient: evaluate the quality of clustering using the silhouette coefficient. Elbow method: plot the sum of squared distances within clusters against the number of clusters to identify the elbow point. Dendrogram: visualize the hierarchical clustering process using a dendrogram to identify potential cutoff points.